Hello and welcome back to another episode of Advanced RC Adventures. A2RC here. This is a channel where we investigate, explore, build and explain, upgrade and advance Nitro RCs to another level. Come start a new adventure with me. Today we have a fun Nitro Engine Overview with an HPI Racing NitroStar, as they dub a high performance engine. This is the NitroStar T3.0. Has a pull start. We're going to go ahead, open up the box with this brand new engine and take a little adventure together. We have it here in our bubble wrap. This engine is brand new, like I mentioned, but it has been taken apart, cleaned, and lubricated, inspected, and resealed into our bag. Let's pop this open and start the adventure. Take out our desiccant packet. It's always great to put a brand new one of those in your sealed engines if you can, especially for long-term storage. Let's do a little walkthrough here. NitroStar HPI Racing engine. Notice that when you go back and look at the G3.0 overview, the backplate and the pull start on this engine is different. And there's a little bit of differences between the G and the T3.0 that we're going to discuss. We're also going to do a little bit of comparison to 18 CVR components, since this is a direct competitor of that engine. Now, the 18 CVR is long discontinued from OS, but we're going to use it as a baseline of comparison for this T3.0. So like all the engine overviews, we're going to take this carb off. We're going to pop off the back plate and pull start and the head, and let's have some fun doing it. So take off this pinch bolt here. This uses a standard 6mm pinch bolt. There's a number of different similarities or the same shared components between the T and the G 3.0 version. So this effectively is the exact same carburetor. It uses a 2 O-ring style, one down below that goes down into the throat, and one up there. They're both black butyl O-rings. This uses a kind of a standard rotary carb style butyl boot. This is a 2-needle carb. We have our low speed here on the mixing cone side, and then we have our high speed needle there on the inlet. I believe this is all brass construction, but this is chrome or nickel plated here on the housing that has the high speed needle down inside, a polished brass inlet nipple. 90-something% of this carburetor is composite. It does its job. It is a 6.5mm bore. And while we're talking about it, let's take a look at the OS 18 CVR carb. This is a 6.5mm bore down inside as well. This is an 11J. Uses one butyl O-ring there for the seal. A similar type of construction for the inlet and high-speed needle. One main difference is that the opening here uses a 15 or 16mm filter, so for the big block style filters, so 21 and up, it uses that style throat, but it still has a 6.5mm venturi down inside. Let's do a little bit of measurements here to do some direct comparison. So this is an 11mm throat. This is a 10mm on the T3.0. So that sacrifices a little bit of airflow. Let's go ahead and measure this upper portion too. So this is a 9.5 or 10. They call it a 10mm. So when you're looking for filters, you're going to look for a 10th scale or a 10mm style filter. Where notice this is a 16mm, which is comparable to the big blocks. This is a 2-needle carb as well. This utilizes a low-speed needle, but it's a little bit different. This is on the spray bar side. Generally speaking, the low-speed needles that are on the spray bar side, you can have a little bit more consistency on the low-end tune. Notice here on the inlet nipple, there's no adjustment. Is how the T and the G 3.0 carburetors are set up. Pretty much a similar kind of idea for the idle gap adjustment. Both rotary style carbs, but just a couple different comparisons and looks at and some similarities between the two carburetors. If I had to choose between the two, I definitely would pick one of the OS carbs. OS has some of the most consistent and best tunable type of carbs out there, even on these RTR and club race style engines. Let's pick the engine back up. This is a side exhaust engine, very similar to the 18 CVR. This is a standard shaft engine. All the T3.0s come with a standard shaft. The 18 CVRs you could get both in an SG shaft style engine, a short shaft, as well as a standard shaft. This has integrated engine mounts. The 18 CVR did not, but you can still use the auxiliary engine mount flanges. Let's pop off this back plate and keep it going. So when taking off your pull starter, a lot of the newer style pull start housings have a retainer inside so that spring doesn't come flying out. But it's still good practice to put something in between. Use a hex driver, a credit card, or something. Fit that in between the pull start and the back plate, and you're pressing it together so when you wiggle it off, that one-way bearing does not take that cartridge out. It's going to be a bad day. I've done it in the past, and I'm sure a lot of you have too. If that spring comes out and that cartridge comes out, it's not going to be fun putting it back together. Let's measure one of these back plate bolts here. So this is an M2.5 bolt. Should be about a 6 millimeter long. Yep, it's 6 millimeters long. So that's pretty standard for a lot of these small block engines. So here's something interesting or different. We have Phillips screws or bolts down inside holding the back plate on to the engine. So we have to switch over to a Phillips, which I definitely do not prefer. I definitely would like to have a hex driver on everything. And I'm sure that they use this probably for maybe two reasons. Maybe Phillips bolts are a little bit less expensive, but they're also hidden behind that pull start. So if you wanted a little bit more aesthetically pleasing bolts, you're going to use the hex, in my opinion. And so they can hide the cheaper, less expensive Phillips underneath or behind there. Got our one-way bearing. Give your back plate just a slight turn, a little wiggle, a slight turn, and back it out. So this is the same style starter shaft that's in the G 3.0. It's that cam or ramp style that the little pin on the crankshaft that we'll show you will go down inside, and as the pull start moves, it holds on to that pin. And once the engine starts up, it over revs and starts to spin on there. So in a way, it's kind of a one-way bearing. It doesn't allow the pin to go this way, but it will allow it to go that way. The back plate itself is different than the G 3.0. It's still a great upgrade. We have a butyl O-ring right here instead of that paper or plastic style gasket around the four holes. It is a semi-interference engine. On the G 3.0, we had another cutout here on the side, but this particular one only has that cutout up above for the piston clearance. it's a lot thinner than the G3.0 style backplate as well. It's great to have this dark gray anodizing. It's not quite black, but it is a very dark gray color. Look down here at the internals. We've got that pin down inside. If you're interested to see and hear a little bit more about that pin and spring, you can go ahead and check out that G3.0 engine overview. Let's pop off this head. Take these head bolts out. Let's give them a little measure. They should be the same as the G3.0. This is an M, 2.5. More than likely it's going to be 12 millimeters long. It's 12 millimeters long, so that's the same head bolts as the G. The overall engine weight when fully assembled is a little over 290 grams. I measured it at 291. And the 18 CVR weighs in at 295 or 296 grams. We're going to go ahead and weigh these heads. Notice we got a taller head for the 18 CVR. It's anodized blue. What I really love about the T3.0 is this dark gray, not quite black, but dark gray colored head. It matches the block, and it's not that matte silver or matte aluminum color that the G3.0 has. I definitely would prefer these darker colored heads. Now you can swap out the heads. They're effectively the exact same between the G and the T. So if you wanted a dark head on your G3.0, buy a T3.0 head and put that on there. So let's turn on our scale. Let's measure the T3.0 head first. We're at 66.5 grams. Now we have the 18 CVR. We're just at 70 grams. So not a lot of difference between these two heads, even though the 18 CVR is taller. The fins on the 18 CVR are thinner. Here on the T3.0, it is a little bit thicker. And the other thing to notice is we have the integrated head button with the compression bowl there on the 18 CVR, but notice it's missing here on the T3.0 and the G3.0. So let's see if we can't take out this head button. Let's put it on here. Let's put it back on the scale and see what we have. Now it says 69.3, and let's go back to the CVR head, 69.5. So these two are effectively the exact same weight, but you have a lot more ability and better cooling with this blue 18 CVR head. Both of them are multi-directional flow heads. That means that you can get airflow in 4 different spots. That's the same here for the T3.0 head. So even though they're not compatible, you can't swap the 18 CVR for the T. I would much rather have a bigger, same weight head like this 18 CVR than the T. Again, just another interesting comparison between the two different engine models. So let's keep going here. Let's get our, well, we're going to get our sleeve out, but let's go ahead and talk about our head shims. There was definitely an interesting conversation about head shims when we talked about the G, and there are 2 head shims on the T version, which is very different than the G. The G has 3. If you want to know a little bit more and hear a little bit more about the head shims on that engine, feel free to go check out that video. But let's go ahead and measure these. This is a 0.2, and that's what it's supposed to be. And this is another 0.2. So we have 0.4 shim stack on the T3.0, and that is different than the G. Just something curious to point out on this particular engine. Let's take out the sleeve. Set that to the side for a moment. Let's get this piston out. Let's pop out our crank. And let's take a look a little bit more in depth at the block here. So I mentioned these have integrated engine mounts, but HPI and Force, who builds these engines, still put on the auxiliary engine mount flanges, which is an amazing thing to do. Yes, it's great to have integrated engine mounts. It's one less thing to buy, one less thing to lose or damage, but you still want to be able to use this engine on different setups, and having this auxiliary engine mount flange is very important. You can still have these on here and put that pull start engine mount on there, and you do not have to use those auxiliary mount holes, and you do not have to use those integrated engine mount holes. You can just use the side auxiliary engine mount on the block. These use chrome steel bearings front and rear. HPI on one side, and then on the other side we have HPI as well, but this definitely has a nice shine cut. Down below you may not see it very well, but there are formal cuts out for the side transfer ports, for the boost port, and that exhaust window. Let's take a little look at our crank. Standard shaft. Let's measure our induction bore in the middle, 7.5, and let's pull in the crankshaft for the 18 CVR. Right off the bat, you can probably notice that the induction window on the 18 CVR, which is this one here, is much bigger. Effectively, they're the same style crankshafts. We have a little bit of light weight going on here on the balance lobe for the T3.0, which is a great improvement over the 18 CVR here. Let's go ahead and measure this induction bore. So this is an 8mm induction bore on the 18 CVR, and again comparing it to a 7.5 on the T3.0. So we have a lightweight crank, which is nice, but I would much rather have this 18 CVR with a lot larger induction window and bore myself, but just a little bit of comparison between the two. And then let's come over here to the T3.0 piston. These are the same components as the G3.0. We have that skirt cutout on both sides. Got a captured wrist pin. Brass bushings pushed in onto the billet rod. Let's do another comparison just for fun. Let's go ahead and weigh the GT 3.0 piston compared to the 18 CVR. So we're at 6.7 grams. We have a used 18 CVR piston and connecting rod assembly. Has that skirt cut out there. So 6.7 for the T3.0 and 5.1 for the 18. Let's look at these side by side. In addition, let's measure the diameter of the piston. On the T3.0, 16.85. And on the 18 CVR, 15.98, so effectively 16. And that brings up a topic of conversation. Both of these engines are an 18 size. The overall displacement is about the same, but the way that they get there is a little bit different. For the T3.0, this is a 2.97 cc engine, so effectively a 3.0, and it measures out to be a 0.181 cubic inch engine. But the stroke is very different. So the amount of movement that the two engines make, they're different from one another. On the T3.0, it has a 13.32 millimeter stroke. But on the 18 CVR, it's pretty different. We have a 15 millimeter stroke. So the overall displacement, again, is about the same. We have a 2.97 cc, which equals 0.181 cubic inches compared to a 0.183 on the 18 CVR. The stroke lengths are different. The overall interior sleeve diameter or the piston diameter are different. This G or T3.0 piston is effectively bigger in diameter than the 18 CVR, but the total volume inside of the sleeve and the amount of distance from bottom dead center to the top dead center, that volume is effectively the same, but the way at which it gets there is a little bit different. Diameter is bigger here on the T3.0 compared to the 18 CVR. Notice it is visible. You can see the diameter difference between the two engines. Let's take a direct look at our sleeve now. This is the T and the G 3.0 sleeve. We have a normal rectangular exhaust window. The side transfer ports are a little narrow and okay width, but it does have a decent machined bevel. Same on the other side, machined bevel on the lower side, but the port itself is a little bit smaller. And then we talked about on the G 3.0, this boost port is one of the smallest boost ports I've ever seen, especially in a large displacement engine. So let's do a direct comparison, just because we have them here, compared to the 18 CVR compared to the T and the G 3.0. Look at the exhaust window. We have a pretty standard rectangular size there. We have a lot nicer shaped exhaust window and a lot taller. And there's no dog ears on the side, but we have that basic kind of shape for better outflow of the exhaust on the CVR. Let's go to the transfer ports. There's no bevel on the 18 CVR, but notice the port is a lot longer. They're about effectively the same height, but it's a lot longer, just no bevel compared to the T3.0. And let's go over to the boost ports. Take a look at this difference between the boost ports. Here's the T and the G 3.0. It has a bevel. Look how small that is compared to the boost port on the 18 CVR. It still has a bevel on the bottom. But this is why I truly believe that the construction as well as the design for these 18 CVRs are much superior to the T3.0. We did a direct comparison on drive between the 18 CVR and T3.0, and yes, they did have a similar output power curve and speed to 100 foot, but the 18 CVR definitely outbeat the T3.0. So if you are curious and you want to try to understand some of the basic differences, the 18 CVR, yes, it's a very similar, very much the same kind of power output as the T and the G 3.0, but the CVR family, the OS discontinued family, is just a different kind of animal. The quality of components are there, but the unfortunate thing, they are discontinued, and trying to find parts for these is extremely difficult. The point of me saying is that if you want to go out and try to find an 18 CVR, it's vintage, you may have difficulty, but it's worth getting. If you want a current built 2-day engine from Force, branded HPI, you cannot go wrong for your build with a T or a G 3.0 engine. In my opinion, it's a lot better option than some of the other 18s that are out there on today's market. So if you enjoy these types of engine overviews, especially when we have an opportunity to do a direct comparison on engines from the past and engines that we are currently able to purchase on the market today, then feel free to continue to take these Nitro Engine Overview adventures with me. Feel free to like, share, and subscribe. And if you like 10 scale, nitro, and especially touring cars, then this is the place to be. And thanks for taking the adventure with me.